It's a tool where AI autonomously pentests, where SAST throws out 500 warnings. But having detect, investigate the cause, Strix is layered on top.
Renka, my SAST warnings are over 500, and I'm about ready to give up.
Static analysis warning hell. Are you going through all of them?
I have to, or we can't ship. But like 90% are false positives. And I feel like the real dangerous ones are buried in there. If I check each one asking does this actually matter, development just grinds to a halt.
That's the limit of SAST. It can flag this looks suspicious, but it won't verify whether an attack actually gets through.
Exactly. Once it just throws warnings at you, you still have to build your own repro test to decide.
In that case, I've got the perfect tool for you, Sherry. It's called Strix.
Strix? Never heard of it.
It's a tool where AI autonomously pentests. It doesn't stop at looks suspicious. It actually builds a POC and verifies whether the attack goes through.
It builds a POC, so it automatically judges whether something's a false positive.
Right? It doesn't just say found it. It confirms it actually landed, so only the truly dangerous ones remain.
That would help so much. But is a tool this convenient really that new?
It was released last August, so it's only about 11 months old. But it already has over 39,000 stars.
39,000 in 11 months. That kind of growth for a security tool is insane.
That just shows how many people had the same problem. Let's take a closer look at Strix today.
A tool with 39,000 stars. Isn't the setup a pain?
Actually the opposite. You just run the installer with curl and you're done. All you need is Docker and an LLM API key.
An LLM API key? So AI is required even though it's a Pentest tool?
Because Strix itself is an AI agent. It supports OpenAI, Anthropic, Gemini, and a few others. Set the model name and API key as environment variables, then just run the Strix command.
Is there anything extra you need to install on first launch?
A Kali-based sandbox image gets pulled automatically. It's a Docker container loaded with real Pentest tools like Nmap and SQLmap.
So the AI uses those inside the container to actually attack.
Right, and you can choose different scan targets too, local code, or a GitHub URL. If you give it the URL of a live web app, you can do black box testing too.
Working without source code sounds useful for checking a production environment. You said earlier it's different from SAST. What exactly is different?
SAST is static analysis, so it lists this looks risky through pattern matching without ever running the code. But Strix actually runs the app and tries the attack. It only reports what actually landed, so only real vulnerabilities come up.
Verifying dynamically what's actually running under the hood.
Inside a Kali-based Docker sandbox, real tools that pros use, like Nmap and SQLmap, are running. The LLM combines them depending on the situation and builds out an attack scenario.
So the AI is reproducing how a pentester actually operates.
Right, and it doesn't stop at finding something. It even generates POC code. So the report comes back with evidence, like this attack code actually got through.
Then you don't have to spend time verifying false positives yourself.
Where SAST throws out 500 warnings, Strix gives you something like these 5 are the ones that actually matter.
500 down to 5? That means you could actually handle all of them properly.
It's not about reducing warnings. It's about narrowing down to only the real ones. That's the decisive difference from SAST.
After a scan finishes, what form do the results come in?
The TUI screen shows the detected vulnerabilities as a list. The most eye-catching one is the vulnerability confirmed label. If that shows up, it means the attack actually went through. A confirmed vulnerability.
It's not maybe, it's confirmed.
Each vulnerability comes with a CVSS score too, so you can see the severity as a number at a glance. Then there's the endpoint URL and a description of what the problem actually is.
What kind of vulnerabilities actually show up?
One interesting example was something called order with negative total, a business logic hole that let you make the order total negative.
A negative order, so the store ends up being the one paying money.
Right? That'd be fatal for an e-commerce site. This is exactly the kind of thing SAST can't catch. The report format is well put together too, so you can basically use it as a report as is.
Not stopping at just finding things, but making the reporting part easier too. That really helps. It's great that it finds vulnerabilities, but I'm still the one who has to write the fix, right?
Strix actually goes further than that. There's a tool called Apply Patch. For every vulnerability it detects, it can auto-generate the fix patch too.
A patch too. So detection and fixing happen in one shot.
Right? And the output format is ready to drop straight into a PR or a commit. It comes out as a diff, so you can just copy-paste it into Git Apply.
Being able to apply the fix straight to a branch is really convenient.
Just don't ever merge an AI-generated fix straight to production, though.
So review is mandatory.
Of course, the AI fix is just a starting point. Deciding whether it's actually correct is on you. But having detect, investigate the cause, and draft a fix all happen in one flow is a big deal.
Reviewing a proposed fix is way faster than writing one from scratch, you know.
Detection all the way to a proposed fix in one stop, that's really Strix's strength.
I get that it can fix things, but what kinds of vulnerabilities can it actually find in the first place?
Strix comes with 24 different attack patterns, packaged as playbooks. First, the classic injection family, SQL injection, NoSQL, OS command injection, STI, that kind of thing. Then access control issues, IDOR, authorization bypass, privilege escalation.
Sounds like it covers most of the OWASP top 10?
It's not just that, it covers client-side stuff too. XSS, CSRF, prototype pollution, plus HTTP smuggling and race conditions.
Wait, it can detect race conditions automatically. Timing issues seem like they'd be hard.
The playbook lays out the attack steps, and the AI runs through them based on that. Here's the thing, it also handles LLM prompt injection.
Oh, so it even covers AIR vulnerabilities, so you could test something like your own company's chatbot?
Exactly. You can use it for security testing on apps that have AI built in too.
Does it go through those 24 attack patterns one at a time, in order?
No, they run in parallel. Under the hood, Strix is built as a multi-agent setup.
Multi-agent? So there are multiple AI involved.
Right? A parent agent spins up child agents and splits the work between them by role. They're specialized, one for recon, one for the actual attack, one for post-exploitation.
That's like a Pentest team. Recon gathers intel, then the attack side goes after it.
Exactly. Same structure as human pentesters dividing up the work across a team. And each agent coordinates by messaging the others, while they all work at the same time.
So running in parallel means it can try multiple attack vectors at once.
Like one agent testing SQL injection, while another one is probing for XSS.
No waiting in line, so it can scan exhaustively and still get speed out of it.
A team of specialists moving all at once beats one agent trying to do everything alone, right?
Multi-agent, parallel attacks. How accurate is it in practice?
There's an actual benchmark for it. It's been tested on 104 web security CTF challenges, 100% on easy challenges, 96% on medium.
Nearly perfect through medium is pretty impressive.
Though it drops to 75% on hard challenges, that works out to missing about 1 in 4.
So once things get genuinely hard, even AI still hits a wall.
Also, the average solve time is around 19 minutes per challenge. It takes a fair bit of time. And here's a practical detail. Scanning 100 challenges runs up around $340 in LLM cost.
Over $3 per challenge. That adds up if you're running this continuously.
Which is why treating it as a full replacement for SAST is risky. I think the better approach is SAST for broad, shallow scanning, then Strix to dig deep on the suspicious spots.
Used as a complement, that makes sense on both cost and accuracy. When you think about the cost, running this manually every time isn't realistic.
That's why I'd build it into CI. GitHub Actions can run it automatically on every PR.
So the security check runs automatically before a PR gets merged.
Right? The key is the N option. That switches it into headless mode, so it runs without the TUI. If it finds a vulnerability, it exits with a non-zero code, so CI stops automatically.
So a PR with vulnerable code just can't get merged.
Exactly. Now, scanning the entire codebase on every PR would take a while, right? That's where scope mode diff comes in. It limits the scan to just the PR diff.
Only looking at what changed that should cut the wait time a lot.
If you set diff base to origin/main, it only targets the diff against main. And if you combine that with scan mode quick, you get a lightweight scan that runs fast.
Diff only in quick mode? That actually sounds realistic to run on every PR. Strix is so useful. I kind of want to try it on a bunch of sites.
Wait, hold on. Absolutely not. Strix runs inside a sandbox, but the attack traffic it sends to the target is real.
Real? I thought it all stayed inside Docker.
The Kali sandbox is there to protect your machine, Shari. But actual HTTP requests and payloads go out to whatever you're scanning.
So the other server actually receives a real attack.
Exactly. So the target has to be something you own, or a system where you've been explicitly given permission. Scan someone else's service without permission, and you're looking at unauthorized access charges.
There's real legal risk here. I was about to try this without thinking twice.
It's even in bold in the README. The more powerful the tool, the more responsibility falls on whoever's using it.
Own apps, or properly contracted test engagements. I'll keep that in mind. So it's not about ditching SAST and switching to Strix entirely.
Right? SAST is good at broad, shallow coverage, so keep leaning on that. Strix is layered on top. Its job is to sort out which of SAST's warnings are actually real.
Running the whole codebase in deep mode from the start would eat up too much time and cost.
If it were me, I'd start by building quick mode into CI. Scan just the diff on every PR, so you get a light check every time something changes.
When would you use deep mode then?
For things like a full pre-release check, or a quarterly audit, situations where you can afford the time.
Quick day-to-day, deep at the milestones, knowing when to switch gears matters.
And one more thing, don't just take Strix's results at face value. The AI judgment is a reference, but the final call is a human's.
And review the fix patch properly before merging it too.
Stick to that, and it becomes a powerful weapon for getting out of SAST warning hell.